Good day, ladies and gentlemen, personalities. Today we are going to be speaking about increasing and decreasing functions. All right. So, for example, you do get questions where they say, for which values of x is f at x decreasing? For which values of x is f at x decreasing? All of these kind of questions. Now, the question is, how do you go about answering those questions? That is exactly what we are going to do today. All right, we are going to look at increasing function. When do they increase? When do they decrease? And how do we play around with those kind of questions? Ladies and gentlemen, personalities, this is, I think it's for grade, there is grade 11 work here. There is also grade 12 work. But so grade 12 can use it as what? As a revision. And then grade 11 can also use it as a reflection and a revision, or as that. I do not know what it is. I do not know which level you are in terms of your learning, but all of you will just benefit. If you're already mastering the job, this kind of topic, it can actually work as well, just to help you look at things in another way. So everyone can be able to benefit from this kind of a thing. All right, now let's go straight into the chase. Now, before we do that, ladies and gentlemen, personalities, if you want to become the part of this community, this is Tembela Maths Club, and my name is Mqondes Macaba. So if you want to form part of this community, you can go ahead and hit the subscribe button below. And then if you want to get notifications when I upload a new video, then you can also hit the what you call the notification button, so that you'll be sorted. Let's get that out of the way, and then let us start. Now, ladies and gentlemen, personalities, in mathematics, terminology is very, very important. In my life teaching mathematics, I've seen that in most cases people struggle with mathematics, but when you actually come closer, they are not really struggling. They are just struggling with terminology. Okay, so if I say to you, go to the kitchen and take a kettle for me, if you do not know what a kettle is, then you will never know. Even when you see the kettle in front of you, you can look and look and look and not find anything, and you end up coming back and say, I can't find a kettle. But it's not because you didn't have eyes to see the kettle. It's because you did not know what a kettle is. So in mathematics, ladies and gentlemen, personalities, terminology is very, very important. You must know, you must understand. When they say increase, you must know what do they mean by that, and all of those kind of things. So in this case, we are going to deal with those kind of things like that. So number one, what I want to get out of the way is that when they are talking about f at x, they are talking about y. Most of you should know by now that f at x and y are one and the same thing. So for example, you can have an equation and say y is equal to x squared. Okay, or you can say f at x is equal to x squared. This is one and the same thing. So when they say y, you must know they mean f at x. When they say f at x, you must know that they also mean what? They also mean y. Okay, so when you look at questions, you must be able to identify these kind of things and be able to understand them properly. Okay, now increase. Where do we say a function is increasing, and where do we say a function is decreasing? Okay, so guys, that could be seen, like for example, if you have a graph of that particular graph, because in most cases when you do this kind of function, you already have a graph. When you have a graph, it's very, very easy to see. You can actually see it with your eyes without doing any calculation. So what you should do is to go from left to what? To right. Okay, so you're gonna go from left to right along the graph, along the curve or the graph. Okay, now I want you to notice. So for example, let's say you've got something like this. Let me just use a different color for this one. Let's say you had a graph like this one. Can you see? Okay, and then it is like this. Okay, this is y, this is x, and then this is your graph. Whatever the graph is, we don't really care. So what you should do, let me actually, the graph, let me put a different color to it so that we can be able to explain what I want to explain. So this is the x, the y-axis, the x-axis, and then this is a graph. Let's call it y is equal to f at x. Okay. So now, I want you to listen to this thing and listen rather very carefully. So I said you must move from where? From left to right. So let's say you are here. Can you see that? And then you are moving along the graph. Now, if when you move along the graph from left to right, if you increase, can you see here you are going up? So if you go up, that means f at x is increasing. Okay, so when you go up, so what is happening? It's increasing. Can you see that? Now what if you go down? If you go down, then it means that f at x is what? Is decreasing. Do you understand? Okay, now a case like that will be something that looks like this, where you have a graph, okay, and then this is y, and then this is x, and then you have a graph that is simply like this. Okay, remember, what did we say? You need to go from left to right. So when you are going from left to right here, it means you are traveling here. Can you see? You are going where? You are going down. So because you are going down, that means f at x is what? F at x is increasing. Does that make sense? So you just have to look at the graph and start traveling along the graph. Whatever graph it is, we don't really care. From left to right. And then you must just see whether you are going up or you are going down. And that's it. And that's it, lovely people. That is it. That as simple as it is. Without getting into too much complications. Alright. Now, let's go to the increasing function. Let's explain the increasing function now in detail. Okay, we've explained both. Okay, let's take an example, e.g. Okay, let's draw this function and then let's put it like this. Okay, right, this is y, this is x. Okay, a function, it must be a different color so that we can actually see easily what is going on here. Okay, and then this function, it's something like this. It's y is equal to 2x plus 3, 2x plus 3, and then the x part, the x intercept of this function is minus 3 over 2, minus 3 over 2, and then the y-intercept of this function, so when you close there, what do you get? You get 3, so the y-intercept is 3. Okay, and I'm giving you another strategy. Now I'm throwing off another strategy. You see, when I want the x-intercept, you let y be is equal to 0, so you just close this y, and then you take 3 to the side, it becomes negative, and then you divide by 2. Can you see? And then you get this thing for free. And then when you want the x with the y-intercept, you let x be equal to 0, and then you just put a hand here. There's no 0. Can you see? Then your y is what? Is 3 for free. But anyway, let's pass. Now, the question here, okay, so we've got this 3 here. Let me quickly write it down. 3. So the question here, is this graph increasing or decreasing? We did say earlier that if you move from left to right, if you are going up, then we say what is happening? It is increasing. So we can see it is increasing. Okay, but now how do you precisely put it into context and explain it mathematically, right? So what will happen is you will have something like this. you must just take 2 points. Okay, just 2 points, one on the left, two x values, one on the left and one on the right. You can pick any 2 points. Okay, so in my case, what I'm going to do, I'm going to pick x, which is equal to -1. Okay, so it's something somewhere here, and then I'm going to pick x, which is equal to what? Which is equal to 2. This is on the left, okay, and then this is what? This is on the right. Okay, so now I want you to notice what we are going to do here. So what we are going to do is to find the y value of this point. So take this point, put it here. So when you take this point and then you put it here, so you're going to have what? You're going to have y is equal to 2 times -1 plus 3. Can you see that? And then when you put this on a calculator, or you just calculate it, this is, it's going to be -2. This times this is -2. -2 plus 3 is what? Is 1. So you've got 1 here. Okay, and then here, what did you get as a result of this one? So we've got y, which is equal to 2, and then 2 plus 3. And then what is that? This is 4 plus 3 is 7. Now, I want you to hold it right here. Now, formally, if you pick 2 values, one on the right and one on the left, if you evaluate the function, and then using what is on the right, if what is on the right is greater than the evaluation of a function with the number that is on the left, so what does it mean? That will mean that f at x is increasing. Okay, so if you've got a function and then you are trying to see if this function is increasing, or you want to show that this function is increasing, you can just pick 2 values and then evaluate them and look at the outcome that you got. If the outcome that you get on the right is less than the outcome that you get on the left, then you know that it is what? It is increasing. Does that make sense? I can give you another one. Say x is equal to, just take 1 now, and then x is being equal to say 5. Okay, so when you substitute this one, what are you going to get? You're going to get y is equal to 2 and then 1 plus 3, which is equal to what? Which is 7. And then when you equal here, you will have 2 times 5, right? Plus 3. And then you get what? You get 13. So you get 7 here. And then what you get there? You get 13. Can you see? Your evaluation at the right is greater than the evaluation at the left. So FR is greater than FL. So because of that, the function is increasing. So it does not matter, people. You can pick any value, I don't care, as long as one value is on the left and one value of the right. Okay? Now, if you then evaluate these values and then you find that the evaluation from the right is greater than the evaluation on the left, then for sure, then that is an increasing function. So all in all, I'm saying an increasing function, you can actually see it by your eyes, but now you cannot say in a paper, when they ask why are you saying that this function is increasing, you can't say because I saw it on the paper. You can't say that. You must show. So you can just pick any 2 values and then you can show that if I evaluate the value on the left and the right, the value on the right is greater than the value on the left. That's one way that you can possibly look at it. But ladies and gentlemen, personalities, when you are doing grade 12, there is a very, very powerful tool And that powerful tool is what? Is a derivative. You can actually use it to see if the function is increasing or decreasing. So in this particular case, you've got, remember, you've got y, which is equal to what? Which is equal to 2x plus 3. So when you say dy over dx, which you know that it's called f prime at x, you can use any of the two, it doesn't matter. You know that the derivative of this part is going to be 2, and the derivative of 2, because it's a constant, is going to be 0. So the derivative of this one is 2. 2 is greater than 0. It means 2 is a positive number. That's simply what greater than 0 means. It's a positive number. So guys, if you take a function and you find its derivative, and then you find that its derivative is a positive number, then without a shadow of a doubt, that function is what? F at x is increasing. So mostly when you are doing grade 12 and then they're asking you, is this function increasing or decreasing? You can simply take a derivative of that function, and then when that derivative gives you a number that is greater than 0, a number that is positive, then you know for a fact that that function is increasing. So right now, if you can actually find that question in the paper, now you know exactly what to do. That no, I know what to do. The function is increasing because the derivative is a number that is greater than 0. Does make sense? Right. Now let's look at the decreasing function. Decreasing function. All right. So when we are looking at the decreasing function, let's take an example. It's very nice to explain using examples. So you've got f at x. Can you see this one was y? Now this one is f at x. Again, what we said earlier, f at x and y is one and the same thing. You can use them interchangeably. It does not really matter. So you get minus 3x plus 6. And then let's quickly draw this graph. Guys, you must know how to draw this kind of graph, and you must master drawing graph. It's very important for any mathematician to be able to draw graphs, right? So how to draw this graph? You need to find the y-intercept. You let x be equal to 0, so you just put your finger here. What do you remain with? Y is 6, so you just put 6 here. For free. And then let's find now x. You let y to be 0, so you put, can you see? And then you take this 3x to the side, it's going to be positive, and then you divide by 3 both sides. What do you get? You get x is equal to 2, but you must do it properly when you are doing it. Don't do it like me. Remember, I passed my grade 10, grade 11, grade 12, so I can do this, but you can't. You must write down. Okay, so what do you get here? You get 2, so 2 is here. Say 2 is somewhere here, 2. And then the only thing that you need to do after that, you need to connect the dots. Just connect the dots. Okay, my line is terrible. Okay, your line must be nice, mine is terrible. Okay, so we said earlier we are looking at the decreasing function, obviously, so we know that this is a decreasing function. But let's say you were not told that it's a decreasing function. You know what you would have done. You would have traveled from left to right along the graph, and you can see you are going down. So without a shadow of a doubt, this is a decreasing function. Okay, so now we said to explain properly, we pick 2 values on the left and on the right. Okay, and then we evaluate this value. That means we take this value and we put it into the equation. So let's say the same numbers that we took earlier. Let's take x is equal to -1, and then x is equal to what? Is equal to 2. So with that, you can get y is equal to minus 3, and then you've got minus 1 here, and then plus 6. And this will then give you 3 plus 2. What is 3 plus 2? 3 plus 2 is 3. No, this is not 3 plus 2, 3 plus 6. 3 plus 6 is what? Is 9. Okay, I made a mistake. I hope you saw that. Right, and then let's look at this one. You've got y, which is equal to what? Which is equal to minus 3, and then you've got 2 here, and then plus 6. And then what do we get? 3 times 2 is what? 3 times 2 is 6. Okay, so it's minus 6 because this one is negative. It's minus 6. So minus 6 plus 6, what do you get? You get 0. Okay, now I want you to notice this thing very carefully. I want you to look at this one. Can you see? Here, you've got this number is larger than this number. Can you see? But here, you've got this number that is here on the right being smaller than the number that is on the left. So, what does that say? That says something very simple. That if you have evaluated this thing, if the f that you got from the right is smaller than what you got from left. Therefore, you know that f at x is what? Is decreasing. Okay, so you always have R and L. Can you see? Here, you've got R and L. So if it's greater, then you know it's increasing. If it's smaller, then you know what? It is decreasing. Okay? Okay, you can go ahead and try this for yourself. X is equal to 1, and then X is equal to, say, 5. Okay, you can go and try it on your own, and you'll definitely see that you'll get something more or less like this, and then you will see what you do. Okay, now that is your homework. But basically, now here we connected for grade 12. Now I want to emphasize that this is for grade 12, the derivative part, because the derivative is only done in grade 12. So we use the derivative here to show that this function is increasing. Now, can we use the same derivative to show that it's decreasing? Let's just take the derivative of this one and see where it lends us to. Okay, so we've got f at x, which is equal to nothing other than minus 3x plus 6. When you find f prime at x, what do you get? From here you get minus 3, and then this one will be 0. So you've got minus 3, which is less than what? Than 0. Guys, this is very important. It's less than 0. So what does that mean? That means that f at x is what? It's decreasing. It's decreasing. Okay? So if you've got a number that is less than 0, then you must know that the function that you are dealing with at that particular point in time is nothing but what? Is nothing but increasing. So can we summarize all of these ideas? Can we summarize these ideas? Yes, we can. Now, how can we do that? So basically, in generality, when we are talking about increasing and decreasing function, increasing and decreasing function, say f at x. So what did we say? We said we can see it in how many ways? We can see it in 3 ways. The most easy one is 1 by going from, so we had 3 ways. Okay, so the first way is what? Is you go from left to right along f at x. Okay, and then we said if you do that and you go up then what happens? You know that f at x is increasing. And then what did we say again? We say when you do that and you go down, without thinking, you know that your function is what? Is decreasing. This is the first way to see it. Now, what is the second method? So, the second method is a very simple one again. You pick any number from the left and you pick any number from the right. And then you take this number, so you will have an x on the right and then the x on the right. One on the left and one on the right. And then you find f at that number at the left. And then f at that number on the right. And then we said the two things. We said if f at the right, if it's greater than f at the left, then we know that what is happening? We are increasing. So we say f at x is increasing. All right. And then if we had f at the right being smaller than f at the left, then we know that f at x is what? Is decreasing. That was the second method. And then we had the third method, and we did emphasize that number 3 is not just for anyone, but it's for grade. It's in grade 12. The seniors of the class of the school, of high school. The prom queens and prom kings. And anyway. And then what did we say? We said we use what? We use a derivative. So we take a derivative, f prime at x, right? And then if f prime at x gives you a number that is greater than 0, we know that that is f at x is increasing. Okay, it's increasing. And then we know that if f prime at x gives you a number that is less than what? Less than 0, we know for a fact that means f at x is what? Is decreasing. I'm summarizing this, guys, because I want to do this once and for all. I do not want any one of you missing this. I want you to know that now I'm done with increasing and decreasing. I can focus on other things. Okay. So this is our summary, right? Now, ladies and gentlemen, personalities, with this in mind, let us then take another graph. Let's take y, which is equal to x squared. Okay, and then we all know that this is a graph that is like this. Right? This is y, we know. This is x, and then there is a point 0 here. This is y is equal to x squared. Okay? The question is whether this graph is decreasing or increasing. There's something that I forgot to do, that I always do, to use a different color for the graph so that I can separate it from the rest. Okay, now I want you to look at this thing and look at it very properly. We said in order to check whether the graph is increasing or decreasing, the first very easy way to look at it is to look at from left to what? To right. Okay, now let's do exactly that. Can you see? So what are we going? We are going down. So that means f at x is decreasing. Okay, let's go. Okay, it's decreasing. Okay, now here's a problem. What is happening now? We are now going up. How? What is happening now? We are going up now. So so now it's increasing. So it was decreasing, yeah? And then when you change from here, it started increasing. Now what does that tell us? it tells us that sometimes the graph will increase at a certain interval, but decrease at a certain interval. Same graph, right? So, for example, in this particular, or it can be vice versa. For example, in this particular case, on the positives, remember positive is where x is less than 0. So on the positive, we can see that we are going down. You can see. So what is happening? F, okay, at x is what? Is decreasing. Okay, but now when we look at x, okay, let me write with a different color. When you look at x, that is greater than 0. Then we also see that f at x is now doing what? Is increasing. Okay. Now that is very, very important to note that sometimes the behavior of the graph, whether it increases or it decreases, it changes from interval to interval. That is something that we must always note. We had nice ideas. We had very beautiful ideas. Like for example, when we're doing this, we can see it went down all the way, so we knew it was decreasing, and then here it went up all the way, and then we knew that it was what? It was increasing. So this one was decreasing, this one was increasing everywhere. Okay, so now we can see that sometimes it doesn't happen like that. Sometimes you will have intervals where the graph decreases and an interval where the graph increases, or vice versa. All right. So let's pick another one to illustrate this idea more. Here is a graph. Let's take this graph and say, okay. And then you can see here also, okay, let me do the same thing that I did earlier. I always forget this thing. Okay, I would have said you guys must remind me, but I remember that you are very far from me and it's a recorded session, so you can't remind me. So tough luck for me. Alright, so we've got y here, we've got x here. Now what is happening here? What is happening, lovely people, here? Same way. Same way. So what we simply do is we go from left to right. We always try this one first, because even if we have to prove using either method 2 or method 3, but we must always make sure that it lines up with what we saw here, because this one never goes wrong. Okay. Now, when you go here, what is happening? We are going up, but things change here. Okay, let's note the point where things change. Let me use another color to note. Let's write it like this. Let's call this point A. Okay. And then, okay, now what happened from A? Okay, go down nicely. Oh, now things are nice. The graph is decreasing. I'm going down, so it's decreasing. F at x is decreasing. I forgot to write y is equal to f at x. We don't care what graph it is. We don't really care. But you can see it has 2 turning points. So it is a graph that is what? A cubic graph. Okay, but from here to here, it goes down. Can you see that? So that means it's decreasing. But when you get here, things start changing again. Okay. Let's just put it like this. Let's put a different color. And then let's call it. Let's call this one B. Okay, this is A and B. So, in this interval from A going to negative infinity, what is happening? F at x is decreasing. Okay? And then what happens? Between A and B, what is happening? F at x is, so here it was increasing, so here it is decreasing, and then from A to infinity, what is happening? F at x is increasing, right? So all in all, lovely people, it proves what we said earlier. Here we only had two intervals. Okay, one being decreasing and the other one being increasing. But here you've got 1, 2, 3 interval. In more complicated functions that you will see when you get to university, you can get different intervals. There can be many intervals, and then many things can happen there. But obviously for now you are dealing with this kind of function. So you have 3 intervals there, and then the behavior in terms of whether the graph is increasing or decreases changes from interval to interval. Right. Now, ladies and gentlemen, personalities, I want you to fasten your seatbelt, because now we are going to take off in a very, very different direction. Okay, we have noticed that you will have a function decreasing between a certain interval and then increasing in a certain interval. Okay, now what does that mean? Very, very important to understand this. So now I want you to look at me, and then I want you to look at me rather very, very carefully. Okay, so first of all, let's look at this one. We said at the interval x is less than 0, function is decreasing. Now that simply means that the function is decreasing. Here it is decreasing just after 0, not at 0. After 0 is decreasing. Can you see? And then here it's also decreasing, and then it's also decreasing. But remember, you are going from left to right. So if you call this one, you're going to be confused. So here it's decreasing. So if there is x, remember this is from x to minus infinity. So at x is equal to minus 10, the graph is also increasing there. At x is equal to minus 2, it's increasing. X is equal to minus 100, it's increasing. X is equal to minus billion, the graph is decreasing, not increasing. I hope I didn't say increasing, because it's decreasing from negative infinity up to close to 0. What is happening there? At all of those points, the graph is decreasing. Now let's leave the 0 part. We'll talk about it later. Now, when you are having increasing function between 0 and positive infinity, it means at this point f at x is increasing. At this point f at x is increasing. At this point f at x is increasing. And that leads us to a very, very important observation. Now, what is that observation? Is that if f at x is increasing in an interval, whatever interval it says, we don't really care, interval, then what does that mean? That means that f at x is increasing at all. And let me put this all in different colors so that it is very clear. At all, let me just put it like this. At all points. At all points. Within even the decimal, it doesn't matter. Within this interval, especially for grade 12 people, this is very important to know. Interval. Okay. So if I say between minus infinity and 0, the graph is decreasing, therefore I know that at all of these points the graph is decreasing. But if it's at 0 up to positive infinity, the graph is increasing, then I know that at all points, what is happening? Graph is increasing. Okay, let's continue. So that is one. Let's put it as one fact. Now there is a second fact, which is also very important. Now what is this fact? This fact is that if f at x is decreasing now, this is just the opposite of this one, but I just need to write it for formality's sake. If f at x is decreasing in, actually not in my English being bad, on an interval, on an interval, but anyway, we're not teaching English here, we are teaching maths. So interval, okay, but you must speak proper English. I must try to speak proper English so that I can be professional, okay? But anyway, so if f at x is decreasing on an interval, then this was then, not d. Okay, so then what? Then let me write this one with a different color also. So f at x is, goodness, why is my spelling so wrong? Increasing, what is that? It's increasing. So f at x is decreasing at all, okay, let me write this all again, all points. At all points we fill this interval. I'm writing this in English so that you can see and understand it clearly. That's when we take it and we shift it to our world in mathematics, you will then won't have any problem. Now let's shift it to our beautiful world. So how do we precisely express this in mathematics? It then brings us to a rule. Here is a rule. Now what does the rule say? It says that if f prime at x, remember we said if f prime at x is greater than 0, then we have what? We have an increasing function. Yes. So if f prime, and then we take any point, let's call this point A. If f prime at A, okay, let me actually write it afresh. Okay, it's a rule. So if f prime at A is greater than 0, okay, now what does it mean? This implies that what? It implies that f at x is what? F at x is increasing. Is increase at what? Let me actually write this with the red one. At x value, which is equal to a, because you remember you put x values here. So if I have f prime at a, so I'm going to find the derivative of that function and then take the value of x and put it inside. If I get a positive number, then I know that f prime at x is increasing exactly at a point. Remember earlier we spoke about increasing in an interval. Now we are talking about increasing and decreasing at a point. Okay, and there's no other tool that we use to show that other than derivative. Derivatives helps us so much. That is where derivatives makes our job easy. Okay, now there is a second part to this rule. Now what is the second part of this rule? Is that if now you've got f prime at a being less than 0, now that means what? That means that f at x is decreasing. Decreasing where? at x, which is equal to a. Can you see that? Now this is a rule. Let me put it somewhere nicely so that we can actually. So this rule summarizes all of these things. Okay. Does this make sense? Now, let us illustrate this rule using this function. And then let's see where it lends us to. Okay, so what is happening? So let's take this interval less than 0. Okay, so we've got an interval x that is less than 0. Let's pick any number that is less than 0. Which number? Let's pick x, say is equal to -2. Okay, let's say -3. Well, we can pick any, doesn't really matter anyway. Okay, so let's find f prime at x here. So f prime at x here, can you see f prime at x is what? Is equal to 2x. Can you see that? Okay, now because there is x, remember x is an unknown. Remember earlier when we did this, right? When we found f prime at x, it was a number without any x. So we knew that, okay, this is a number that is less than 0. But here we've got 2x. Now there is x that we do not know, right? So we do not know whether this is positive or this is negative. We will only know that once we've substituted this one. Okay, luckily we have it here. So we can then say f prime at -3. And then that will give you what? 2 times -3. And then what is 2 times -3? 2 times -3 is equal to -6. And -6 is what? Is less than 0. Okay? It is less than 0. So that means that at x, at a point x is equal to -3, the function is decreasing. Ladies and gentlemen, you can check another point. You will see. For example, you can take, say x is equal to, say, -100. You will have 2 times -100, which is -200, which is also a negative number, which will also be like less than 0. And then at that point also, f at x will be decreasing. So it does not matter which number you pick, as long as you pick a number that is part of that interval. Then you insert it in the derivative, and then you will find the value, and then you can decide whether it is the f at x at that point is increasing or decreasing. All right, so we just have to pick one. All right, now let's pick another one here just to demonstrate this one and for all, and then close shop. So we pick x is greater than 0. Let's pick another value. So say x is equal to 10. Obviously, f prime at x, we already know it is 2x. So f prime at 2 is going to be what? 2 times 10, which is what? Which is 20. And then 20 is less than 0. So this one, okay, remember this one was decreasing. So this one is what? Is increasing. You can pick another point and test it for your own, or that is your homework. You can pick any point as long as it's between here, you will see. So this rule does help us a lot when it comes to checking whether a function increases or decreases at a certain point. Then this rule is a way to go. So you must write this rule down somewhere and put it somewhere where you can see it and start practicing so that you can evaluate it. Even here as well, if we had a function here of this graph, we could easily take a derivative of it and then start picking any value that is here. And then so what you will do, and then you decide whether it's increasing or decreasing. You already know by using the first method, the method of just going from left to right. But now you just want a proof that this is a case. Okay. Now I want you to look at this one carefully. Okay, so This is increasing from a to negative infinity. And how to explain that? So at x less than a, it is increasing. And then now here, can you see between a and b? Now you will, how to write between using mathematics? You say x, and then you put the sign, and then you put the first part of the interval, which is a, and then the second part of the interval, which is b. So between x, when you have x values between a and b, then you've got a decreasing function. Okay, but now when you from b up to negative infinity, which is b, is greater than, so sorry, x is greater than b. I'm asking that nonsense. Well, so when x is greater than b, what happens? Then you have an increasing again. So you've got an increasing graph. So it increases in this interval, and then at this interval it decreases, and then at this interval it decreases. So when you look at this and this, you can see you've got increase and then it decreases. They are this point. Now we are looking at the point as an individual, but now you find this point. What is happening at this point? 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 Okay, now let's try and use this rule and see what is happening in this point. Okay, obviously we do not know what the graph is here, but we know what the graph is here. So we're going to use a graph and test this point at 0 and see what is happening. Okay, now let's see and check. Now I want you to be very careful. So we've got f prime at x, which we know is 2x, right? Okay, now we are taking point x is equal to 0. So what happens? So f prime at 0, then you've got 2 times 0, which is equal to 0. So f prime at 0 give us 0. Now here's the thing about 0. 0 is not greater than 0 because it's 0. And then 0 also is not less than 0 because it's 0. So 0 is just on the league of their own. So because it's not here, so it's not increasing. So, and because it's not here, it's also not decreasing. Okay. So we then add the third part to this rule. Now what is the third part of this rule? The third part of this rule is nothing other than a very simple fact. And then which fact? The fact that if you've got f prime at x that is equal to 0, then these points, they are not increasing, they are not decreasing. So what are they? They are stationary. Stationary. What does stationary means? It looks like a very, very big English word. Stationary simply means it's standing still. It's not moving. Okay? When you go in higher mathematics, they will always mention it as a stable point. They call it a stable point. Because things are increasing here and things are decreasing here, but this one is just standing. So it's not decreasing, it's not increasing, it's stable points. That is why there is a video here that we're still going to put together and put there. I do not know. Maybe by the time you look at this video, it will already be there. Let's talk about stationary points. So when we speak about stationary point, what are those stationary points? Stationary point is where the graph changes in it from increasing into decreasing. So we've got very, very nice word for turning point. We call it for stationary point. It's calling in normal language. We usually call it turning. It's turning point. Okay. That is why when you are looking for turning point, especially in a cubic function, you grade 12s, you always find the derivative. And then when you find the derivatives, actually there is a video already on this. You can go and check it out if you don't understand this part. You find a derivative, and then when you find this derivative, you then do what? You then equate it to 0, because we know according to this rule, you can see that if f prime at x is equal to 0, then you've got stationary points or you've got turning points. Now, in the context of what we are doing now, it is where the graph will change from increasing to decreasing. It will be a tool that we're going to use to mark those intervals where the graph increases and decreases. It's a very, very lovable and awesome tool. All right. So when we find turning point, we're just going to find f prime at x and then equate to 0, and then we'll definitely find the turning points. All right. Now, ladies and gentlemen, let us prepare to close shops. Now, in all of these things, we then find what? We then find that actually one of the jobs of calculus is to help us to know whether the graph is increasing or decreasing. There are many uses of calculus, but one of them, remember earlier we did what? We did the equation of a tangent. It's one of the applications of calculus to help us find the equation of a tangent. But another function of which we are dealing with now precisely is to actually show us. Where the graphs increases and where it decreases. So it's one of the use. So basically what we are currently doing is the application of calculus. A sense of it, the one part of it that shows us whether the graph increases or decreases. Okay, so when they ask you for which values of x is this graph increases, you are going to use exactly this. You are going to use calculus, especially in grade 12. If you're in grade 11, please don't use calculus because they will ask you where did you learn it from. It's not part of your syllabus yet. You must always answer questions in terms of in line with what is happening in your syllabus. But you grade 12s, you are going to use calculus because calculus is part of your grade 12 CAPS syllabus in South Africa. All right. So when they say for which values of x is the function increasing, you're going to use this. Now, as I close this job, I'm going to show you exactly how to go about with this kind of question using some of the things that we have done. And then after that, we'll close. Now, ladies and gentlemen, let us go back to the main reason why we're here in the first place and answer those questions. For which values of x is blah 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 blah. Let us close on that note. So we're gonna start with this function, the increasing function. Let's say they ask you a question. They say for which value. Now I want you to notice when they write these things, guys, they always say value and then they put this s. What does this mean? It simply means for which value or values, because sometimes you can have just one value, sometimes you can have more values. Okay, so for which value of x is f at x, and then number 1, let's say increasing, and then let's say number 2, for which value of x is x decreasing. Okay, so we did say, what did we say? We're going to take a derivative. We've already have a derivative. It is 2, right? It is 2. Now, because it is 2, it doesn't even have a value of x. 2, that means everywhere. f prime at x at any point it is greater than 0. Okay, because there is not even a chance to substitute values. You can't substitute because there is no x. So all over here, f at x is increasing. Now, how do you then explain that mathematically? So, okay, you are explaining that it is increasing everywhere. Okay, you can write everywhere if you like. I don't think some math teachers will mind, but more precisely, they usually write it like this. They will say, in any value of x that is an element of real numbers. Or you can write it properly and say f at x increases for x is an element of real numbers. So, which means that everywhere. Okay, so for which values of x is f at x decreasing? Okay, because it's increasing everywhere, then there is no value of x for which this is decreasing. So what are you going to say? You're going to say exactly that. You'll say no value of x. Okay, or you can just write it in a full sentence. Okay, I prefer you write it in a full sentence. Don't worry about me. You write it in a full sentence that there is no value of x for which f at x is decreasing. Okay, but increasing there is. Okay, so sometimes when they ask something, sometimes it is there, sometimes it is not there. If it's not there, that is also an answer. Remember, you're supposed to give an answer. Okay, if it's not there, you must write exactly that it's not there, so that a person who's marking will see that you know your story. Okay, let's pick up this one. For which values of x is this increasing? Okay, we look at the derivative again. If there's no derivative, then it means you find it, but luckily here we already have it. It's minus 3, which is less than 0. So we don't even have a chance to check values. There is no value. So for increasing, if they say for which value is f at x, number 1, increasing, and number 2, decreasing. So in the increasing part, you just tell them that there is no value. Okay, what about decreasing? It decreases everywhere. You can write everywhere if you want to, or you can just write properly and then say at the value of x, which is an element of real numbers. Remember, guys, we've got something called a real line. A real line is simply all numbers. It involves all numbers from negative infinity this side up to positive infinity this side. Okay, so when you say x is an element of real numbers, you are simply saying in English that this is true for all values of x that you can ever find. Okay, now let's go further, and then let's look at this one. Okay, but before we look at this one, there is this one that I'm really interested in. Where is it? Okay, here it is. Let's look at this one first before we go into this one. Okay, let's look at this one. All right, now let's say they're asking the same question. For which value of x is f at x, number 1, increasing. They don't have to ask everything, but sometimes they ask everything. You just have to look at what they ask. Decreasing. And let's say this side, they also ask in number 3, neither increase or decrease. Okay, so how to go about and answer these kinds of questions. Okay, so you are going to look for a derivative. A derivative, you know it already. It's what? It's 2x. But now you must check here, you've got two intervals. It's not the same as what was happening here where everything was increasing and everything was decreasing. So you remember we said from negative infinity, if x is less than 0, what is happening? It is decreasing. But now, when you want to show that, what do? We can say f prime x is equal to 2x. And then what you can do is we can pick any value. Okay, you can pick any value. So which value are we going to pick here? Let's pick any value, as long as that value is less than 0. Let's pick -2. So when you pick -2, it's going to be 2 times -2, which is -4. And then, okay. And then so in this interval, it's decreasing. Okay, so we're going to answer decreasing first. So it is decreasing when x is less than 0. Okay, but guys, you don't just write this like me. You must explain properly. Okay, and then show your derivative and show unless they say, if they say use the graph, then you don't have to show how you calculated. You must just observe and then say. If they say use the graph, you must just give the answers. But if they don't say use the graph, you must show them. You must show them that you've calculated the derivative and then you've picked any value in the interval and then you've checked it. Okay. And then what about increasing? Increasing, you can see that it increases from 0 to what? To positive infinity. So that is x is greater than 0. So it increases at x is greater than 0. Now, where is it that is neither increases or decreases? Is at x equal to 0. Okay. Wonderful. Now let's look at the last one. Now this is the last one. And then we can close shop. Okay. Now, they say consider the following curve. And then they've written the curve, they've drawn it for us. Guys, I think I should mention this carefully. It is not always the case that they've drawn the curve for us. It is not always the case. In most cases, not in most cases, I'm not talk nonsense. In some cases, you will find a curve being written. In some cases, you will have to write the curve yourself and then find this derivative and all of those. So this is why it's very important, guys, to know how to write a curve, because if you wrote a wrong curve, then they will ask questions about it, and then obviously you wrote a wrong curve, so obviously all your answers will be wrong, and then you will start losing marks. Okay, obviously you won't lose all marks, but you lose significant amount of marks, and obviously nobody wants to lose marks. I don't want you to lose marks. So you must know how to draw graphs. If you do not know how to draw a cubic graph, there is a video here. You can go and check. Now what is happening in this in this YouTube channel? There are some groups. There are some topics per group. You know, so for example, this part will always be in calculus. Okay, I've combined calculus and application to calculus into one. Okay, so you can just go in and check there. You will see a graph that talks about how to plot a curve, and then you can learn how to do that so that you don't get it wrong. Okay, but anyway, we're not there. Let's go on. So number A, what are they saying? For which value or values of x? Now, I just want to, before that, we said value of values. And then I emphasize that sometimes it's a value, sometimes it's interval. So in an interval, there are many values, but when it's one value, it's one value. So when they're saying value of values, they are actually taking that into consideration, that it can be just one value, but sometimes it can be more than one value. Okay, so here they are saying exactly that for which value or values of x is f at x increasing. Okay, So luckily we've got a graph already, and then let's just add the parts using the graph. Using the graph. Okay, but sometimes they won't say that. Okay, so which values of x, for which x is increasing, we know. Okay, let's see. Okay, let's go from the left. We know we are increasing. We've found the first one. So the solution. So it is increasing where? At x is less than what? Minus 3. That's A. But now when we get here, what happens there? It decreases, it's no longer decreasing. Okay, so we jump this interval. But when we get here, it starts increasing again. So how to express that mathematically? You say x, where x is less than 0, or every time when you say or, you must know you jumped a certain interval, or x is greater than, so this is minus root 2, and then x is greater than root 3. Can you see that? So now, in most cases, you had normal intervals, but now you've got an interval with an or, which means you go along and then you jump and then you get another interval. Okay, now let's look at the second one, B. For which value or values of x is f at x decreasing? Okay, we said already that it's increasing here, so it can't decrease. But from this point exactly, hey guys, I think I've just committed a big mistake. This is a proof that everyone can commit a mistake, including teachers like myself. There's something that I said to you earlier, but now I'm the first one to violate that. I said the stationary points, they will give us the intervals. So I think before we can even put this on, let's scratch this one because this is not the one. Let's scratch this one. Let's actually put the intervals so that will make our job very easy. Okay, let's do this. Okay, what are the intervals that we have? Let's just write the sign line. Okay, if you do not know how to draw a sign line, there is a video here that talks about that. Okay, it talks about inequality. Then you will see how to do a quadratic inequality. Go and check quadratic inequality. That is there is, I think it's in algebra. Yes, you will see it then. But okay, check this one out. So the x value of the turning point is -1. So that will be the point of departure. Can you see that? And then you will have another one being what? Being 1. That's the point of departure. So let's say it's -1 here and then 1 here. So in this interval, what is happening? It is increasing. Let's just write for increasing. Let's just use a different pen. It's increasing. And then between this, what is happening? It is decreasing. Let me use a different one. It's decreasing. And then what is happening here? Guys, this strategy is actually working. Yes. Tap dance. Okay, you must celebrate when you've done something well. Okay, so it's increasing and then it's decreasing, and then what is happening here? It's also increasing. Can you see that? Okay, you must always put dots. I'm being lazy here. You must always put dots to show that it's not a full word. You're just lazy. Okay, you were just lazy. Okay, so it's decreasing, it's increasing, and then it's decreasing and decreasing. So now when you've got this, you can then answer any question. So for A, so now let's start a new A. So for A now, where does they want the values for which f at x is increasing? So where is it? It's at less than 1, not less than 3, because it's decreasing here. When you go, remember we said we must go from left to right along the graph. Can you see? Before you reach -3, it's increasing, right? Even at 3, it's still increasing. Even after 3, so it was nonsense to write that between this one and this one this is increasing at this in the demarcation of this point. I was talking nonsense. Okay, you can't say I'm talking nonsense. I can say I'm talking nonsense because I'm the teacher, must you know. Okay, cool. Let's continue. Right. So this is a demarcation. So it's x that is less than what? This is less than minus 1, or x that is greater than what? 1. Guys, I want to assure you with this one. Guys, please. Okay. Guys, if you did not have this turning point, you can take this graph as it is, and then you know what I told you to do. You find a derivative of g prime at x, and then you equate it to 0, and then you can find turning points if you don't have one, because you can't do this without turning points. You can't say the graph is increasing way and decreasing way, especially when you are talking about this kind of a graph, the cubic graph. Okay, so anyway, yes. So number B, what is happening? Number B, they want the values for which this is decreasing. You just go back to the table that you made. You say decreasing between minus 1 and 1. So what do you do? Okay, let me use something else. You just say put x here, and then you put less, and then you put less here, and then you put the first one when you go from left, that is minus 1, and then where? And then 1. Okay, and guys, also please note the fact that there's minus 1 and 1 here, it does not mean it will always be like that. Sometimes it will be different numbers. Sometimes it can be 1 here and then 4 here. It doesn't matter. It always depends on what are your critical points or what are your turning points. Okay, so let's do the last one. Here's my favorite color, which is blue. See, find the value of values of x for which f at x, what did I do here? F at x is neither increasing nor decreasing. Okay, now I want to recall what we did earlier. That here there was x is equal to 0, because that was the turning point here. And then obviously here we're not asked. But if you were to be asked here, there wouldn't be that point, because all the points are decreasing here. And then here all the points are also what? Are also increasing. But I want you to notice in this particular case, as opposed to this one, here there's only one turning point, here there are two turning points. So now the graph, the value of x for which this point is neither increasing or decreasing is what? Is x is equal to the first x of the varying point, which is minus 1, not or, and x, which is equal to what? These are value, right? This is a value or values of x, where the graph is neither increasing nor decreasing. Ladies and gentlemen, personalities, this was a very long video, but it was worth it. There's a lot of things that we can get through. So, and guys, you know, people are struggling with this thing. Send, share with them, share it. Now the best thing to reach out to people, because obviously you've got people that you are friends with, maybe you are studying with on Facebook, and then you just want to help them out also, so that they can also get hold of this work. Just share on your own. Just share this message on your own, what they call this thing, on your own Facebook account, so that they can see it from there and then start watching and then benefit as well. All right, it will help me, but more than all, guys, it's not me that is the most important part here. It's about you guys being able to pass. Okay, and I know not all of you have internet, but some of you at your schools, there's some internet there. You can just sit down in the corner and start watching these videos and start practicing, and then you pass, because there's no internet at home. We're not coming from the same homes, and we're not coming from the same financial background. So that is purely understood. Okay, so ladies and gentlemen, personalities, when they say for which values of x is this function increasing or decreasing, or neither increasing or decreasing, now you know exactly what to do. Ladies and gentlemen, thank you very much for tuning in. This is Mqondisi Macaba from Tembela Maths Club, a club that helps learners to understand mathematics. Thank you, happy learnings, and goodbye.